one of the questions that we get asked a lot is, so, how do I figure out what to put in for the ventilation and recirculation error numbers? So we can help you figure out what the design conditions should have been, but as Danny said, really there should be at least some spot check measuring to kind of verify what you're actually getting, because most likely it won't be what the design conditions are and there's a huge number of reasons why that's the case. But to give you a place to start, if you want to start with just figuring out the ventilation air, the outside air, there you can access ASHRAE 62.1. There are read-only versions that you can access through the ASHRAE website. The link is given here. And then you kind of scroll down till you find the maximum ventilation rates and breathing zone tables. And one of those tables, or part of that table, is shown here on the right. So to calculate it, that second set of bullets kind of discusses how to do that, but I'm just going to use a specific example to demonstrate how it's done. So let's say I've got an art classroom that I want to figure out what my ventilation rate at least should have been from a design standpoint. So if you look over here in the art classroom, the first thing we need to do is figure out what the design occupants should have been to calculate the ventilation rates. And so there are default values given in this column here, density values. So it's for the art classroom is 20 per 1,000 square foot. And so you just multiply that times the square footage in your space. So in this case, it's 1,500. And so the total occupants is 30. That's what I use to calculate the required ventilation. So then that ventilation number to calculate it is based on understanding or estimating what's required from the number of occupants I have in the space, the design that I just calculated, as well as the square footage. So there's two components to figure out. So the first one is you take the CFM value per person, which is 10 in this case, and multiply that times a number, which was 30, which you just calculated, so that's 300. Then you need to add the additional amount per square footage. So I've got 0.18 square foot per CFM. So I multiply that times the 1,500 as well, and I add that together. And so the total ventilation from a design standpoint, at least to start with, is 570 CFM of outside air. Most likely, systems aren't delivering that, or at least parts of the year they may not be delivering that for a variety of reasons. But that's a place to start. So then how do I figure out what my recirculation error is? So in that case, recirculation error is just your total supply air, subtract a ventilation error from that. And so then you need to kind of figure out, so what's my total supply air? So as Danny mentioned, you can reference as-built mechanical drawings if you have them. Typically on the drawings, you'll look for them on the plans. A lot of times next to the diffusers for each space that lists the CFM that comes out of each diffuser, that's total. And you add that up per room, and that's your total CFM per space. If you don't have access to that or don't really understand what you're looking at on the drawings, there's a very rough, and this is very rough, the rough rule of thumb that outside air is 20% of your total supply air. So you could divide your outside air by 0.2, and that gives you your total supply air, or at least a rough approximation. So then in that case, for the art classroom, then if, let's say I didn't have drawings and I'm just using that rough rule of thumb, my total supply air would then be 2850, 570 divided by 0.2, and then the recirculation error is the 570 subtracted from that 2850, or 2280. So that's a place to start. But like I said, there's lots of reasons that may not be the case. Then you really should probably involve an engineer or a commissioning agent to kind of help you look at your system, verify, do you have outside air dampers that are closed shut that you don't realize? Is it winter conditions and the system, the way it's set up, ramps down outside air much more than what that ASHRAE recommendation is? There's lots of reasons it's going to vary, and so it's not a bad idea to at least do some spot checks. And there's a really good guide for if you're a facility manager to help you figure out how to do that on your own. It was produced by the Harvard University here, and there's a link to it. And it walks you through. It says for classrooms, but you could use it for multiple building types. And it walks you through detailed steps on how, and it's not that hard, on how to do it. Some cases there's some equipment required, but if you don't have that equipment, there's alternative ways to measure it without it. So it's a really good way that you could do some spot checks in your buildings to verify what you're actually getting. And then for selecting the portable HEPA filter units, our tool will help give you at least a rough indication in terms of what those impacts will be from a risk standpoint. But there's a more detailed tool to help you walk through selecting them. Here that Harvard and CU Boulder put together, it's also really good. I highly recommend referencing it. Now, unfortunately for upper room UVGI systems, if that's something you're really interested in looking at, you're going to need to talk to a consulting engineer and manufacturer and contractor to help you get that done. It's not something you can do on your own.